All right, today we are going to talk about perimeter and area of similar polygons. So again, things to remember about similarity is that we have two figures, two polygons, and they are the same shape, but they are different sizes. So today we're going to be able to figure out the area and perimeter of similar figures. So let's talk about similar figures and corresponding sides. So if two polygons are similar, okay, then the ratio of any two pairs of corresponding sides are equal. Now, something that we have to remember, and it's kind of the way that I kind of just think about things so that I don't get confused, is that a ratio is just a simplified fraction. All right, and it is used to compare sizes of similar figures. Now, a ratio may not be the actual measurements. Is it sometimes? Yes. All right, so for instance, we could say this has a ratio of 2 to 3. Well, does that mean that these side lengths are always going to be 2 and 3? No, because we could actually have side lengths that are 4 and 6, and that ratio, see, 4 over 6, this is a fraction that we have made to compare side lengths, but if we reduce it, now we get a ratio. Okay, so we use the fraction to compare things, and then when we simplify it, we call that the ratio. So a ratio, it is used to describe how the figures are related in size. All right, a ratio represents the simplest form of geometric figures. So again, it's very important to say, okay, this is a fraction that I made. Okay, now how does that relate to the size? How are they related? Now I'm going to call that a ratio, 2/3 when I simplify it. All right, so if two figures are similar, or polygons, whichever, if two polygons are similar, the ratio of their perimeters will equal the ratio of their corresponding side lengths. So that's something to really pay attention to. So for example, 4 to 6 are the side lengths. So the ratio of the sides would be 2 to 3. All right. Now, if I wanted to talk about the perimeter of these figures, the perimeter is also going to have the same ratio. So if the sides are in a ratio of 2 to 3, then the perimeter is also, the perimeters are going to be in a ratio of 2 to 3. Okay, so side lengths and perimeter, they are always going to have the same ratio. Now, area is a little bit different. So if two polygons are similar with lengths of corresponding sides in the ratio of A to B, so whatever the ratio may be, 2 to 3, 3 to 5, you know, whatever it may be, then the ratio of their areas is always going to be that ratio but squared. So it's going to be A squared to B squared. All right, so ratio of the areas can be found by squaring, right? Squaring, raising to the second power, the ratio of their lengths and or perimeters. So let's look at how this all plays out. So find the ratio of the perimeters and the ratio of the areas of the two polygons. So let's always first find the ratio of the perimeters. Okay, so again, to find a ratio, I'm first going to make a fraction, and perimeter ratio and side length ratio are equal. Okay, they're always going to be the same ratio. So if I take I'm going to say, okay, this side corresponds to this one. So if I set this up, hey, I've made a fraction. Now I need to reduce it so that I can therefore call this a ratio. So if I would take a 2 out of that, then that is my ratio of side length and perimeter. Okay, so this is the ratio for the perimeter and the side length. Now, if I wanted to find the ratio of the area, all I would do is take this ratio and I would square it. So therefore, the ratio of the areas of these two similar figures, 1 squared is 1 and t squared is t squared. So this is the ratio of the areas. Again, we're not finding the actual area in this problem. We are just finding the ratio. And again, so remember what that means is if I were to find the actual area of these figures, this is what it would reduce to. All right, and we could do that. We could say, okay, the area of this is 6, the area of this is 6t squared. Okay, so this is the actual measurement. Remember, a ratio is just a representation of the actual. So if I set this up and then I reduce it, you will see that this is the ratio of the area. But you didn't even really have to do all of that work. As long as you know the ratio of the perimeters, then you can square it and find the ratio of the areas. All right, so here again in number 2 in the diagram, triangle ABC is similar to triangle DEF. Find the ratio of red to blue of the perimeters. So again, I'm going to set up, I'm going to say, okay, this side corresponds to this one. So that would be 8, 12. Always, 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 always reduce fractions. So if I reduce this, if I take a 4 out of both, that's going to leave me with 2/3. Okay, so this is the ratio of the perimeters and the sides. Now, a ratio can be written as 2/3. It can be written as 2/3, or it can be 2 to 3. So these are all different ways to write a ratio. Whichever one is comfortable. I mean, these first two are usually what you're going to see most. Now, to find the ratio of the areas, do I have to actually know the areas to do this? No, I just take the ratio of the perimeters and area. Think about area. When you always think about area, that's two-dimensional, and always your units are units squared when you're dealing with areas. So think about it. You have to take this ratio and square it because area is always units squared. So 4 to 9. So what this is saying is if you were to find the area of these triangles and reduce it, it would come out to 4/9. So in number 3, we're just going to complete the table. So again, we're going to just use a ratio given and find the rest. So ratio of side length to perimeter. They're always going to have the same exact ratio. Okay, again, these are all one-dimensional things. Okay, now our area is two-dimensional. So you are going to then square. So 2 squared is 4, 3 squared is 9. So this is the ratio of the areas. Okay, ratio of perimeter is always the exact same ratio for the side lengths. And then to go from these to area, you square it. So 3 squared is 9, 5 squared is 25. Now, when we need to go from something of area that has been squared, right? This is units squared, and we have to go this way, we're going to have to square root it. So the square root of 36, right? That gives me 6. And the square root of 25 gives me 5. Now the perimeter ratio and the ratio of the side lengths, they're always equal, so 6/5. All right, now we can use similarity and the ratio to actually find unknown area and perimeter. The polygons are similar. Find the ratio of shaded to unshaded, of the perimeters and of the areas, and find the unknown area. All right, so first, these are side lengths. So I'm going to set up the side lengths as a fraction, and then I reduce it, and I get a ratio. So this is the ratio of the perimeter and the sides. So I'm just going to put the P and the S. So this is the ratio of the perimeter and the sides. Now, if I wanted to find the ratio of the areas, I'm going to have to square this. So 1 squared is 1. 4 squared is 16. So my ratio of my areas is 1/16. Now, I can use this to actually then find the area of this larger rectangle. And the way you do that, so remember when we did similarity, similar figures, right? A ratio is telling you how proportionate they are. And so I bring that word proportionate in so that you know to use a proportion. Okay, so you got to remember again, we are trying to find area. So everything here needs to represent units that have been squared. So when I put numbers in here, I'm going to use the 1 and the 16 because they have been squared. Now I'm going to put, okay, the area of this little one is 3 feet squared. Well, where am I going to put it, on the top or the bottom? Well, since it's the smaller one, I'm going to put it with the smaller number. So since the smaller number's on top, I'm going to put the smaller area on top. I don't know this one. Cross multiply and solve. So now you know the area of that bigger rectangle is 48 square feet. Now, when you divide 3 divided by 48, don't you get 1/16? Yep. All right, so here you go. Let's do it again. We need to find the area of the smaller, what looks like trapezoid. So we're going to first set up our fraction that of the information given. We're always going to reduce that, so take a 3 out of both. So this is actually the ratio of the perimeters and the sides. Okay, now if I want to find the ratio of the areas, I need to square that. So 3 squared is 9, and 5 squared is 25. So 9 over 25 is the ratio of the areas. So now I'm going to use this ratio to actually find the area of the smaller figure. So again, I'm going to create a proportion. If I'm finding area, everything in here has to represent something that has been squared. You cannot put 3/5 right here because that is a representation of perimeter. We're talking about area. So 9 over 25. We're given the larger figure, so I'm going to put the 225 down with the larger number in the ratio. I don't know this. So we're going to cross multiply. 25x equals, and then you are going to do 225 times 9. So remember, I did give you a link to download this calculator emulator on your desktop. It is in Canvas, so make sure you look for it. So this is 2025, right? And then we are going to divide that by 25. All right, there's my area of the smaller figure, and it is 81 inches squared.